I was trying to show you what a nuclear reactor's fuel rods versus control rods look at like. And if you look at that right corner picture, the bottom are fuel rods, and then in the top, those silver, well, they're all silver, but the fuel rods look kind of clear. Those silver rods coming down into the fuel rods are the control rods. So if you notice, there's a whole bunch already in there because they're absorbing the neutrons while the other ones are producing fission. I also wanted you to look today, while we cover this information, at what the map looks like of the world and nuclear power. And look at the United States, look at Florida. We have a lot of nuclear power plants in Florida. We have a lot in the United States, and we have one very, very close to home, okay? So keep that in mind. All right, so this is another view of what a reactor, what goes in the reactor vessel is these cylinders that contain these fuel rods. And look at the uranium pellets packed in there, okay, undergoing fission. This picture right here is a picture of a containment structure. So you could see, I mean, look at the material behind it. It's like I mentioned, made out of concrete and steel. And that's a pellet of uranium up close, okay? So today we're going to talk about advantages and disadvantages to nuclear power. And with advantages, we've kind of already talked about them because we questioned, why did we even consider nuclear power an option? So what are the advantages to nuclear power? It produces a lot of heat. We can't say energy now because when I teach you about what's happening with nuclear waste, you're going to see that the energy is actually very, very inefficient. It does produce a lot of heat. So initially, it's going to produce a lot of energy, but over time, it doesn't. What else? Not really. Why did we think of why we chose nuclear power? I gave you those. There's a lot of it. I mean, although it's non-renewable, it's found in most rocks, right? So there's a large supply of uranium-235, so we don't have to worry about limited supply. It will run out once it's used, but we still have a lot to utilize. What else? What else did we consider a reason to switching to nuclear power? I'm going to change this a little bit. I'm going to say low environmental impacts on air and water, okay? Or whatever, without accidents, especially reduction of greenhouse gases like carbon dioxide, nitrous oxide, all of that, okay? Now, we've got a lot of problems, and that's what we're going to focus on, okay? Because this is like a second time I tell you why we use nuclear. What are some disadvantages? Who could tell me? What do we got to worry about? Highly explosive. We got to worry about accidents. Okay, what else? We have to worry about waste. Waste is a super, super duper big problem. If anything, I'm going to say it's the #1 disadvantage to nuclear power. And we're going to talk today about low, medium, and high levels. What kind of waste is it? Radioactive waste, okay? So it's radiation. We have to worry about that. What else do we have to worry about? We do. We have to worry about war and nuclear weapons. And then the last thing is, if I have an arrow showing like energy, what do you think I'm talking about? It's less efficient. So because of waste, nuclear energy is the least efficient form of energy to produce electricity. Now, what does that mean? Who can answer that? What does that mean to be less efficient because of waste? Yes. Correct. It takes energy to deal with the waste. So what you're putting in is less than what you're getting out if you look at the whole system, okay? When you look at initial nuclear pellets providing fission, it's a lot. But when you deal with the waste, that drops. So the efficiency is considered the least efficient form of energy. So let's talk about the last disadvantage, which is power plants actually have a lifespan. So here it says 70 years, but they average anywhere between, I guess, 30 to 70 years. Power plants are built knowing that they have to decommission the reactor cores and the containment structures and rebuild those areas if they want to continue to produce energy. So many power plants will have 2 reactor cores, and that way they could decommission one and keep the other one producing energy and making money, because of the amount of radiation that the power plant gets subjected to. It literally has to be rebuilt. All right, so waste. We're gonna focus a little bit of time on this. There's 3 ways to look at waste. So what is this word tailings associated with? What kind of waste? No, this is in your notes. Tailings is waste from what? Mining. Good. So uranium-235 is found in most rocks. We call it an ore because it's a valuable resource, right? And with the mining of uranium, there's tailings, and we consider that low-level radiation. It has to be dealt with like any waste in nuclear power. So starting from mining, we already have a problem with waste. And in addition, anybody that's mining or in the plant or any part of the production of uranium pellets and production of fuel, their clothes and any tools and articles of cleaning products they use also are considered low-level radioactive waste and have to be discarded. Which that's our next chapter is waste in general, but we're gonna reintroduce radiation because we have to talk about it here. We move on to what we call high radioactive waste, okay? And they call this intermediate because this is the highest level, which is what? What's the highest level of radioactive waste? What is this reaction right here? Fission. So when uranium goes through fission, we call that fuel spent fuel once it no longer can produce heat, which, by the way, takes about 3 to 6 years. So yesterday we were questioning how long, and I said, I think it's around 3 to 6 years. It is. So that fuel will produce heat for 3 to 6 years, and then they have to discard it. They call that high-level radioactive waste. The actual reactor or any parts of the plant that have to be decommissioned are considered the intermediate level, but it's still high radioactive waste. So who knows what we do with this waste? Correct. So for a long time, we took any of this waste right here, any kind, high, low, doesn't matter, and we put them in these, what are these? Barrels. We literally put them in drums, steel drums, and we buried it or threw it in the ocean. Today, we only do that with low levels of radioactive waste. We take those, what's low level again? Give me an example. Clothing, any waste from the mineral, right? Or the ore, I should say, or during the mining. We put them in these drums and we bury it. High level is a whole other ball game. Now we take high level waste and we dump it in what the plant has had to build, which is called a fuel pool. That waste, and if you read books 10 years ago, books 20 years ago, they would put it there for 3 years. In the beginning, they didn't put them in the pools. I'm telling you, they took it and they encased it in these steel drums, and then they dumped it in the ocean, or they buried them. Straight out of the fission reaction. They no longer produce fission, we're gonna bury it. Now we leave it in a pool for 20 years, up to 20 years. They basically are waiting for that radioactive emissions to diminish to the point where it's safe to bury. And then they look at the size of those drums. They pack those drums with pellets. And right now, this map right here is pointing to an area in the United States called the Yucca Mountain. You have to know that, by the way. This is where we're burying our waste, inside a mountain. So these are accidents. We had one in United States, 3 Mile Island, partial meltdown due to human error and mechanical issues. This is the disaster of the world, probably the biggest environmental disaster ever, which is in Russia, in Chernobyl. It happened in 1986. And if you Google how many power plants of nuclear power were built after this, you'll see none until recently. They really, really got scared. This dome you see here is basically a structure that is built to contain the amounts of radiation that are still being emitted, because there's still uranium pellets in there. This is the second dome, by the way. The first dome was built by Russia. The second one was built by United Nations because their fear of the radiation leak. So here's a little video that I want you to watch about it. Remember this? There was an earthquake or a tsunami, and then basically what happened was there was nothing to power the cooling system, and then there was a lot of scary fear, I'll tell you that much. Yeah, and I have a video too. If I have time, I'll show you that one too.